Hi, for this video, we learning Euclidean geometry under the subtopic known as the circle geometry. So basically, you have a circle. No, it doesn't look like a circle. We have a circle. That's much better. We have a circle, and in a circle, let me just make it bigger. As bigger. No, that's bigger. No, better. Cool. So we have a circle. In that circle, we have O. We call that point O. That's your center, right? And you have a couple of things going on here. You have a point from you have a point from that, and then you have a chord that goes from here to that point, and you have another chord that goes from that point to this point, right? And you have another chord that goes from this point into your center, and you have another chord that goes to this point to your center, and you have another point that goes to here to the circumference, another circumference, and another point that goes here to the point. Okay, and I want you to notice is this all of this segments, all of these chords, they subtend from the same segment. All of them, they come from the same segment. I want you to notice that. Okay. And then there's a theorem that says that an angle at the center is equal to twice the angle at the circumference. Meaning, if you have an angle here, let's call it this angle 2x. Alright, for argument's sake, I wanted to really make a point around this. Let's call this angle x. Right? So this angle x, if this angle here at the center is x, then the angle at the circumference is twice. So the angle at the center is twice the angle of the circumference, meaning that this angle here is half x. And also this angle here is half x. Why? They're all subtended by the same segment. All of them are subtended by the same segment. So if this angle here is x, then these two angles are half x. Right? Even if we could have another one, if we could have another chord subtended by this segment and this chord here, the angle will still be half x. Alright? So the theorem says that an angle at the center is twice the angle at the circumference. Without exclamation mark, of course. This is important. You're gonna use this for a lot of your questions. All right, let me give you a question around this. All right, you have no, you have you'll definitely have like a circle. Okay, and in that circle you'll have a center. Let's call it O, and you'll have two radius like that. So meaning that you have two radius from that subtended by the same segment, and you have another radius, another chord coming from. I don't want to introduce the diameter yet. Okay, so if something like this, and then you are told this is 30, already not even 30, let's call it 60 degrees, and this is your x, and the question is find x. Okay, find x, and x is simple, right? X is simple. This is your x, this is your 60 degrees, and these both are subtended from the same segment. So what is your x? You're going back here. You said this is 60 degrees and this is our x. So if this is 60 degrees, that means this is half 60 degrees. You see that? So since this is 60 degrees, therefore x is half times 60 degrees, which is 30 degrees. So your x is 30 degrees. And the reason for that, so you can just give your nice reason in there. So your reason is, a reason would be the angle as center is twice the angle at the circumference. Nah, I don't write circumference like that. Circumference. That's your reason. And you're going to use this for quite some time. So it's very important that you understand it and you run with it.